Hello, my name is Jatak and I am here to present our major project for fourth year 2024-2025 on democratizing AI for MSMEs with small e-commerce language models. My team members are Ritesh Bhalerao, Saili Kavatkar and Om Kulkarni, and our mentor is Ms. Sangeeta Oswal. So what our project is aiming for is basically medium and small scale enterprises cannot afford empirical large language models like ChatGPT for all the AI needs. So we are proposing small parameterized language models which can be run in-house, and what differs is our model is fine-tuned on e-commerce dataset, which gives its performance on par with the large language models. Major advantages for this is reducing cost, in-house infrastructure, and faster inference speed. So for our project, we are using a dataset which is the EC instruct dataset. It is an e-commerce instruction fine-tuning dataset which has 263,000 samples which have 10 e-commerce related tasks which like sentiment analysis, recommendation, product classification, product substitute identification, and many more. This is one example of the dataset. An example would usually contain an input, output, and an instruction what we are expecting. So these are the task database view. Like these are different e-commerce perspective and 10 different tasks how they suit the e-commerce perspective. For example, for user understanding, we have sentiment analysis and recommendation, and also for product understanding, we have product relations, product matching, and attribute values extraction, and so on. So about our dataset contains an in-domain and out-of-domain test set to check the performance, how our model perform not only on in-domain dataset but also data which is not related to fine-tuning, which the model has never seen before. So this is our fine-tuning flow. We have taken small language models like small LM2 or Llama 3.2. We pass on the instruction tuning dataset, which will usually contain the instruction inputs and outputs. And after fine tuning, we get a fine-tuned model. This is an high-level diagram of how the fine-tuning works. So yeah, this is in detailed implementation, the model setup, the pre-processing pipeline for our tokenized text, and the configure training. We have used PEFT and LoRa. So LoRa adaptation for using minimal parameters, and also parameter efficient fine tuning, so that we don't have to fine tune the whole model but only a few layers, so that we can get optimum results with minimum amount of training. And after that we get a fine-tuned small language model, and then we will evaluate this model with comparison to the other large language models. So this is the performance of our small language models. As we can see across all the tasks, the small language model, fine-tuned small language model either performs better or it performs almost the same as the large language model does. This shows that a fine-tuned small language model can be used as a drop-in replacement to using expensive large language models. And this is like out of domain performance. Over here also, the fine-tuned small language models perform better. Then part 2 of our project is related to data curation. For this, we are taking the original EC instruct dataset and adding an extension of adding like reasoning steps. So for this model, the model will uh, not only have input and outputs, but also have reasoning steps which will guide the model to reach the outputs. So this is the data curation flow. We have taken the EC instruct data set, and then there is an input and output and also instruction for each data point. So we are using Qwen QWQ 32 billion parameter model with AWQ quantization, and this Qwen QWQ model is used to generate the reasoning steps so that we can curate the whole data set. For the generation parameters, we are using NVIDIA L4x4 temperature of 1 and other hyperparameters. And after running this, we have a new data set which not only contains the instruction input and output, but also the reasoning steps with it. So this is a dataset example for reasoning dataset. What's different is in this, there is a uh, generation value, which basically tells what the reasoning is behind generating a specific output, and then there is a reasoning instruction. So thank you.